Hi everyone, this is Ms. Helms, and by the end of this video, you should be able to determine equations of lines that are parallel or perpendicular to a given line. So in this first question, we're asked to determine the equation of a line that is parallel to the line in the graph below, and then we're also asked to determine the equation of a line that is perpendicular. So what we learned previously is that parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. So the first thing that we need to do is calculate the slope of this line. So to do that, we're just going to go ahead and look at any 2 points on this graph. We'll call this point A, and we'll call this point B. A is at the point -2, -1, and B is at the point 0, 2. So to calculate the slope of this line, we have the difference in our y values, so -1 minus 2, over the difference in our x values, -2 minus 0. And simplifying that, we have -3 over -2. A negative divided by a negative is positive, so the slope of this line is +3/2. So now we're going to take what we learned previously and apply it to determine the equations of these lines. So first we know that parallel lines have the same slope. So if we wanted to write the equation of a line that's parallel to this line, our slope has to be the same. So the slope of a parallel line would have to be 3/2. So in our class, we're going to use the slope-intercept form, which is y equals mx plus b. So our equation of our line would look like y equals, we want to use the slope so that the lines are parallel, so y equals 3/2 x plus some number. This number can be any number as long as it is not the y-intercept of the current line. The reason this number cannot be the y-intercept of the given line is if it was, it would be the exact same line. So they would no longer be parallel, they'd be the same line. So for example, I can say the equation of a line would be y equals 3/2 x plus 6. That would work. But maybe my partner says, no, I don't like 6, I want to use 7. This equation also works because the key focus here is that the slope is exactly the same. Therefore, these lines are parallel. So again, it can be any number as long as it's not the y-intercept of a given line, because that would give us the exact same line. The next part of the problem asks us to find the equation of a line that is perpendicular. Well, we know that perpendicular lines have opposite reciprocal slopes. So that means the slope of this line has to be the opposite reciprocal of +3/2. So the opposite would be negative, and the reciprocal would be 2/3. So the slope of this line has to be a -2/3. So similarly, we're going to use the slope-intercept form, which is y equals mx plus b. Our slope is going to be a -2/3. And for our y-intercept, we can use any number because we no longer have to worry about it being the same line. So this y-intercept can be any value. Maybe you want to say that this is a -3. You can put that there. Or maybe you want to say that this was 27. You can use any value in this spot because in our class what we're focusing on is really the slopes of these lines. So we're trying to identify what is the relationship between the slopes of parallel and perpendicular lines, and we're not necessarily focusing on the exact equation of a specific line. In future classes, you will learn how to find specific lines, but for our class, our focus is really just determining the slopes and then coming up with the equation of any line. Nice work!